Hey everyone, today I'm building something very practical, an REG application that helps real estate investors research tax lien redemption rules across Colorado County. But here's the twist, I'm building it with AI. So with using Claude Code, and you will see me delegate the entire features to Claude, review the code it generates, and deploy a working application. So by the end, you will have a template for building your own RAG application for domain specific knowledge base. So let's dive in. So this is what we want to build: a tax lien research assistant or a RAG project that would allow us to upload the data that we want, let it vectorize our data, and over the chat we can talk with the AI, and the AI will be able to look into the data that have been vectorized into the database, find the most relevant information for you, and put into a nice response for the user. And this is what we want, so we could ask us a question, and hopefully you can see here they are able to look into the vector database that based on information that it has, put and respond to you. If you ask something that it does not know, then it wouldn't respond that way. What's the weather today? Yep. So let's follow this tutorial, and this is the end result project that we want to build. So let's get started. So first of all, before we get building the application, we need to get a brief understanding of what is ARG, right? So let's get to that. Create new nodes. Okay. So what is RAG? A lot of people have a misconception between ARG and MCP, but ARG is an AI architecture pattern, right? It's different from NCP. NCP is more like a tool set that will be available to the AI. The way we build those two gonna be completely different. So we need to get a basic understanding of what is REAG. So REAG is short term for Retrieval-Augmented Generation. So what does that mean? So when we build a UI, we're gonna take it, right? So this is the user, and the UI will be a layer separating the process, the backend. So this is gonna be the UI, and we are the user. As the user, you will send a query to the AI, and the assumption is the AI will respond with the generation of contextual data, respond to your question, to your query using external data that is assumption to be correct. So how does that work in the process? Essentially, first of all, we need to have data. In this particular project, we're gonna be using MD file, which is text pretty easy and clean, because if you use any other product or file format like PDF, that you have to convert it, extract the text from the file before you can process it. And here we can have the empty data, right? It's gonna have a lot of stuff in there. So it's gonna have data, and this is your MD files. So how does that work? We need to upload to the UI, and the purpose of the project is you're gonna build it from scratch with all functionality, especially the data, the function to ingest and convert the input into vector, so that later on you can query against that same data set. So what happened when you send that data to the UI? We're gonna create the app so that it will be able to convert that data through the UI into vector data. So in the back end, it's gonna be converted to vector. This is all the vector data. And that is where the data gonna have IDs, or any amount of IDs that you want. Essentially the number array. So this is gonna have a lot of numbers in there, right? You can have many number, depends on the size of the model that we're gonna be using. And essentially the other part of the data is gonna be the text, or you can call it metadata of the data chunk. And you can have a lot of these, right? So this is what happened when you convert to the vector data. And from that part, when assumption that you ingest the file, convert to the vector data, the user gonna be sending the query. Your query gonna be any questions, right? Any form of text. So this is your query. So you're gonna send the query to the UI layer. In the back end, the query can also be converted to vector data. So we're gonna have the number array. Well, you actually only need the ID. You're gonna have the number array with a lot of numbers. Same thing. That is the same size of dimensions alongside comparable to your vector data. So why is that? Well, we can explain in a little bit. So your question can be anything, right? So what's the weather like today? That could be your query. And essentially after you convert it to vector data, it can be compared against this data set and find the closest vector to it. That's where the data lie. That's where you have all the data. After it's able to find the context, whatever the amount is, we're gonna return it. This data gonna be generated. We're gonna build a prompt. So this is where the prompt's gonna be built. The prompt gonna consist of 3 parts. First part is the context that you found in the data set. The response data set, it could be anything, right? That's the context. And then you're gonna have the actual query from the user, whatever the query may be. And the third part will be the instructions on how to process the context with the query. an additional instruction on top. Like, for example, if you know response, if you don't know, then just say no or something like that. So this is where you build the prompt. The prompt gonna be sent to the large language model. That's the generation part. And then the prompt gonna respond. The large language model gonna process the prompt, and it's gonna respond to the UI to the user. So then you're gonna get either answer, right? Today is good, or I don't know, whatever the response may be. So that is a high level architecture of this. And where is the RAG part? Well, look at it this way. The process of us retrieving the vector data is the retrieval part, and the part where you augmented the response vector into a prompt is the augmented part. And finally, where you go through the whole LLM generation and create a human response to a user, that is where the generation comes from. So it's both using the large language model generative part and also factual context created by the external knowledge that were created or given by you, right? So a lot of the AI usage online is mostly generative model, which is the model was trained on knowledge. However, there's a lot of hallucination going on, so that the data is not entirely accurate. That is fine for most residential use. As in casual user, things can be correct, things can be not correct, and it will also be fine most of the time. There's not major concern to it. However, in business use, you don't want that, especially in area where process and context and everything is very important. Essentially, rules and SOP, right? So standard process and process operation. Every step of the way, instruction information has to be accurate and referenced so that we can always retrieve the original information to compare it to. Today when we build the application, our application gonna be in the real estate sector. It's gonna be about tax lien. That is where my expertise is, because I'm a real estate investor, and I do tax lien. So that's a use case that is real, used by business. And when you do when you apply AI to the business sector with real project, that is where you're gonna find the specific way of implementation and usage of the AI model. Most of the time, you don't use generative randomly. It has to be a specific use case. So that is, the high level understanding of what is RAG, so Retrieval Augmented Generation. This is the AI architecture pattern that you set up for large language model. Now, there could be some questions. So it's like, okay, so we have the data, we know AI, generative AI, you give a text to respond back, but in reality, how do you actually convert your personal data into vector, and then how do you find it, right? How do you compare things? Well, we're gonna answer that question. So the first one is how to convert data to vectors, and then the second one is how are the vectors compare. Well, let's tackle number one. So for number one, how do you convert the data to vectors? So this is where you have to first to pick the model that you're gonna use initially to support your application process of converting the empty data, text data, images, audio file, PDF, whatever, into vectorized data. And the model that we're going to be using to build this project is OpenAI text embedding 3 small. So it's going to be the the text embedding 3 small. Why we pick it? Are there any other model you can use? Yes, there's a lot of model with different company. We pick this one because it's a good size, and then there are different reasons to it, and of course we can dive super deep into this. That's a different video we can talk about. You can use other model from other companies as well. Google has a model as well, and we can use this model. And specifically, these model are supporting embedding. That's the key features. For the model, they were trained specifically to able to convert data, translate data into vectors. So how does that actually work? You send in text and it returns you an array of vector? Well, because when we pick the model, this is a crucial thing that we'll talk about is the dimension of that model support. So what are dimension, and what dimension is it we're currently using? So for this particular model that we're using, the dimension is 1536. And these are 1536 dimension. That is how long your example XYZ, etc. And then the size of your vector array is 1536 numbers. It's long. That they call dimensions. Why? Because mathematically that's what it is. When you have a vector, you have one as a dot, you have two of them is XY coordinate, right? And the XYZ, that's a 3-dimensional vector. So now with this, how do you actually use this? Well, because the model has already been trained by the company creating their model. So what are the dimensions anyway? Well, when you give it a string, it's gonna look at the model. The model gonna be actually been trained on so dimension 1. Let's see. Dimension 1, how is this related to legal, right? So that's will be a questions. How is this? So then it's gonna be dimension 2 all the way to 1536 different dimension, and each dimension is talk about each of these dimension is actually an aspect or a feature of the meaning of a word. So this is where, that's why AI researcher may have a lot of researcher to create data set and then train these model, because you need to understand when you train these model, they can determine, okay, so how is this related to legal? Well, the model can say up is 0.12. That means it's not related. And then, well, how is this related to, let's say, time, right? So there's going to be a bunch of this, and the model can respond like, oh, this is a word meaning related to time. It's going to be, highly relatable. Or it can be, something along the way of, hey, how is it related to your aspect or feature, whatever that aspect or feature gonna be. And it could be negative, 56 or something, whatever the number may be. So after all of this data is returned, and voila, you have a vector of 0.2, 0.98, 0.056, blah blah blah, the whole long array. This can now be stored into the vector database, right? This is gonna be stored here. That's where the data gonna live, right? So that's where it is. Now, when the user send a query like, what is the weather today, that query will also be turned into a vector. This is where the vector gonna be, and we need to make sure that we use the exact same dimension when we parse or convert the data from text to dimension. Well, because that it make it comparable. Well, we can ask questions like, oh, can we use different amount of data of dimension? Yes, you can use more dimension. There's a lot of model that have more dimension, model that have less dimension. Less dimension have less accuracy, more dimension have more accuracy, right? Because you give your chunk of text, you know, all aspect of what that chunk of text is about, and it's the size produced. So it depends on the data output where things are. You're gonna be able to store depends on what you want. So let's see. One second. And okay, so we have answered the first question of how to convert the data into vector. Now you know like how to it work in the back end to actually convert it. Now your raw text will be converted automatically to the vector side. And the second question that we were gonna talk through is how are these vector compare. So we're gonna talk about that, and it's all math stuff that most people hate. But it's actually pretty fun a lot of time. So now well, when you look at this way, how do you find similarity? Now you have the database with lots of vector. Now you have your input vector. Well, what they're gonna do is they're gonna calculate the closest distance from your query to any of these vector in the database. And mathematically for vector, how do you calculate distance? So there's are three different way to use this math in AI and to vector against vectorized data. So there are three different calculation, right, to use against this. So I'm gonna tell you one is the Euclidean. This is C. Euclidean. Euclidean distance, short for L2. And this is the cosine similarity, and the third one is dot product. This is college math. Dot product. Dot product. Most people are gonna hear about because you learn through calculus. You're gonna see it. And cosine Euclidean is gonna be not as often unless you major in math. So hey, if you are any math major out there, hey, don't panic. There's a lot of work for you, right? So and well, these are three different ones. Essentially the text embedding that we use most of the time gonna be used with cosine similarity, and that is the function that we use to calculate the distance between the two vector. Well, so let's see. This is 1, 2, and 3. What is Euclidean distance. So Euclidean distance is actually the square root of, well, actually give an example would be beneficial. And let's look at this way. This is visually looking at the data. This is your x and y graph. So when we call dimension, fancy word, but it starts with one-dimensional, two-dimensional, and three-dimensional, and then up from there. So it's gonna be this as an example, right? So let me clear this and make the example a little easier to see. So this is x, this is y. You're gonna have the data, and this is an animal vector, and this is gonna be the human vector. So when the user input cat, right? When the user input cat, I can't spell today, cat. So when you draw the cat vector, it's supposed to be very close to the animal vector, and that is how you're gonna determine that the cat is an animal. That's how AI will, based on this rule, understand that cat is an animal. And if you put a man in there, right, the man vector can be close to the human vector. So the response gonna be a man is a human. Great. Does it sound well? If people are concerning, how do you get the distance between these are being the shortest? Well, the example that we can use is, let's say your query, right? Your vector is 3, 4, and we have 3 vector in the database. Well, they're gonna be 6, 8. They're gonna be 4, 3, and this gonna be 5, 1. So when we talk about the Euclidean distance, the formula is actually square root of x1 minus x2 square plus y1 minus y2. And then this is gonna be square. So how does that work for A, B, and C? Well, we're gonna have something like this, right? So you're gonna have, since 6a and 3 squared, you're gonna have 3 minus 6 plus 4 minus 8 square, square, and you have root of them. So it will be root of 9 plus 16, right? 3 minus 6 is negative 3, square is 9. 4 minus 8 is negative 4, square minus 4 square is 16. So you have this, and 9 plus 16 is 25. Square root of that, you're gonna get 5. And same here, so you're gonna have 3 minus 4 square plus 6 minus 3 square equal to 1 plus 1 square root equal 1.41, and then you're gonna have 3 minus 5 square plus 6 minus 1 square root of that. 4 plus 9 and 3.61. So for Euclidean distance, they're gonna be checking for the closest. This is the closest distance between them. So now, when do we use this? When do you actually use Euclidean distance? So the Euclid is pretty basic when when you need the absolute position matters the most, and when this is when you're trying to find similar RGB color. In image comparison, what is the closest looking things, right? Because what happened is you don't want to finding similar, you want to find like the closest looking. For example, you saw a cat, you like it, you take a picture and you want to find what that cat is. If it's a black cat, you expect to find on Google a black cat. You give it to the AI will respond, give you pictures of black cat. That means they use a Euclidean distance to compare against its own internal database or external database, wherever it is. Now, if it doesn't use this, you will see random thing like, oh, you give it a picture of a cat, and then they will give you a random cartoon picture of a cat, just because fact it's also a cat, right? A cat is a cat, right? But yes and no, the cat is a cat, but not all cats look the same. And then the second one that we're gonna do is the cosine similarity. This is where you look at similar things. So how does it look? It's actually the A dot B divided by absolute of A multiplied, oops, I hold it too long, multiplied by absolute of B. So that is the equation we're gonna get. And well, that is one part, but then cosine similarity, it first it measure the angle between vectors. It ignore the magnitude. So first we need to calculate the magnitude so that we can remove it out of, well, not remove, but we can ignore it out of the question. So what is the how you calculate magnitude? So your query vector is 3, 4. So how you calculate the magnitude of that, it's gonna be the square root of your x squared plus y squared. So 4 squared, and this gonna be 5. And you're gonna do the same a b c. So when you do absolute value of these things, you're gonna have these, let's say 10, 5, and 5.1. Okay, this is ugly. 5.1. So when you do the actual calculation of A is 6.8, so we remember, and this is how it's gonna be. So against your query, right? So 3 multiplied by 6 plus 4 multiplied by 8. So it's gonna be the dot product. This is the dot product divided by the magnitude of, well, the magnitude of both query divided by 5 multiplied by 10. So the end result gonna be 50 and 1. Wow, we have a 1. That's great. And this is would consider a perfect match. So when you can do B, C, will be gonna be for 3 opposite of the query itself, and it's gonna be 5, 1. So 3 multiplied by 4 plus 4 multiplied by 3, 5. It's gonna be 12, 24, 25. It's gonna be 0.96. This one is 3 multiplied by 5 plus 4 multiplied by 1 divided by 5 multiplied by 5.1. 15, 4 equal to 19 divided by 25.5. You're gonna get 0.75. So these calculate, and how you see that it's scaled back to 1, right? So that is where the magnitude of how long the vector gonna be ignored. And this is why it's called similarity, because now in this particular one, if your text has a bunch of the word cat and your search is cat, then it's gonna find your answer is gonna be that long text of a lot of words, a lot of cat word. So what is the use case? Text embedding. This is where because we want to find similarity. What is similar to the query that we asked about? We asked about the weather. The weather gonna be cloudy, gonna be sunny, right? It's weather related. It's similar. It doesn't matter if the weather is, the text is about cloudy or storm. Weather gonna be related to cloud more than related to animal. So that's how things are your case would be actual text embedding itself, right? And your directions gonna matter more than the magnitude. The third and final one is dot product. Sound very similar because this is college math. So what is the dot product? We see it's A dot B, the first part, and I mean that's what it is, right? X1 multiply with x2 and plus with y1 multiply with y2. Q versus your A, your B, your C. So I mean this is your dot product, right? 1, 3, 6 for A plus gonna be 18 plus 32 equal 50 times 4 plus 4 times 3 12 24. Yeah, it will be 24. This is gonna be 3 times 5 plus 4 times 1. It's gonna be 19. So what's the winner? The winner gonna be this one because it's the biggest. It's the highest. So when do you use this? Well, you use this when your embedding already normalized, or so this is also text embedding. Well, not text embedding, but more like embedding in general, where your data already normalize, or magnitude matters. I wouldn't say more than direction, but it carries a lot of meanings. Has meanings, and what does it mean that they have meanings? Well, example would be in your data set you would have let's say reviews, right? Your reviews, you review A and B and many more. This is called, I like action, comedy, whatever. In this reviews, I really like action, comedy. This create magnitude when you embed the data into the vector. So this is the top is a small like, and the bottom is big like. So when you search text, who like action. If you use a Euclidean distance, it would actually give you the top, because that's the closest string you're gonna have. This string gonna be way too far out or further out. So then if you Euclidean distance, we get this. If you use cosine similarity, it will ignore, and actually it will give you both. So these will be, well, more like these will be ranked among the top results, and then depends on the generative model. Like, oh yeah, both A and B like, right? But then when we use dot product as the comparison, then it gonna look like who really like action comedy movie, right? So they return B. B is your result from this particular answer. So this all depends on the use case, what you want to do, what you search against the data, so that it will give the result that you want. So yes, that is in a sense what goes under the hood of REAG. And now with this understand, hopefully my explanation has been clear and make it easier for you to understand that on the surface, this is what the user see, right? This is all they see. You give it some data, then you ask it, hey, what's the weather today? And then what you expect is in a couple of seconds, the large language model will return, well, this is today. In this particular example, we're gonna give it text data that is rules for tax lien in Colorado. And then we're gonna ask that, hey, what is this rule? What is that rule? What is the redemption period in this particular county in Colorado, or in Colorado itself? And the expectation is the large language model gonna return with like, hey, the redemption period is this, redemption period is X, redemption period is Y, whatever the result is. Or I don't know what you're talking about, I don't have information that context. That is what we expect. So with this, hopefully we understand, and now we're gonna go to the second part where we start building the actual application. And with this knowledge in mind, then the whole process gonna flow by pretty quick. You already understand what is RAG and each particular part on why it indexes the data into the vector, how it calculates and expect the return. So the second part will be super easy. All the prompts that we use will be part of the GitHub repository, so you can download. For now, just go along. You don't have to type out everything, and everything will be included in the either the description or the link to the GitHub repo, so you can practice as well. So yep, so let's get to the actual building part. Okay, let's get back with the building application part 2. So now let me share. Okay, so this is where we gonna start building the actual application. Let's go open Visual Studio Code. Let's give it a folder. And yep, let's create a new folder here. Make a new folder. This is gonna be YouTube rug tutorial. Open it. Let's have Claude Code up, where we gonna have, well, you can use either the plus or the max plan. I think both will work. Here is the first prompts that we're gonna give it. A bit long, but this is where you're gonna create a Next.js project with TypeScript for tax lien, right? We're gonna use this folder. This folder. Okay, so we're gonna use Next.js 15 with app router, and it create the base for Tailwind CSS with CN UI. Pretty much it's gonna use Postgres as a separate service. We can host this on Railway, and I'm gonna show you the whole setup on why we pick Railway. It's gonna be visually very easy to use. So let's run this, and don't worry about it. Typing this code in, all this script and prompts will be included in the GitHub. So just follow along for now. And as you can see, as we put it in, how they can start to get everything set up and install, right? So you can list create to do and start working on it. Throughout this, I will just fast forward through a lot of stuff. And as you can see, Claude Code basically create the entire project structure, right? Using Next.js 15, it's installing everything we needed, and the configuration. So with the new very simplified configuration, this really take about 20-30 minutes normally for a person to manually set this up. But with Cloudy, it handles everything in seconds. So you can see it's already done most of the setup, start installing things, and now you can show that it set up the folder structure with the app, the lib, and everything, and even create a get ignore file, which is pretty good. That's what we want most of the times, and a little bit it'll sync it at the end of the project. I'll sync it, but for most cases, you will want to have this all your projects saved, so you don't have to repeat a lot of project. And it even let's see where we at now. Okay, it gonna create, oh, it even create a environment variables, right, with all the placeholder. I will this is where we use OpenAI key, your OpenAI key, where we'll be able to successfully run the text embedding logic, as well as the generation prompt that we're gonna do at the very end. Database here will be Postgres. We'll be using Postgres with pgvector, basically an extension that allow Postgres to hold vector, huge long vectors. So that will be useful for our purposes. So while it's installing, oh, actually it's almost finished already. So let's see. Yep. So what we'll be able to do here is we can go to localhost 3000. Hopefully it's up. Is it not up? Let's put it aside. Let's look at what the Claude has built for us, right? So the app structure, the layout, the pages, the upload page, and chat page, everything. Oh, okay. OpenAI put in there, and the schema. Well, right now looking at the local, but we will connect in the actual database in a little bit. Okay, so let's look at this. Let's open terminal, npm run dev. Yep, it's running all right. This is where we see it. Oh, missing negative field. We'll copy this error, give to Cloudy. Oh, wait, it's reverting back to Tailwind CSS3. Actually, no, well, sometimes see, if it fails setup, they automatically revert to a low version or a more common setup that I guess it's statistically known to have worked. So let's see if it worked. Initially I want to do it Tailwind 4 because it's newer. I think the setup changed, and a lot of time when things are really new, the AI doesn't have a lot of training on the setup. So sometimes when they fail, it has to actually look online and set up again. Yeah, see, it's CSS board version 4 fail. Okay, see when 3 work. Run enough. Yep, it worked. It has it's really nice, clean nav menu. Purpose of the app, upload docs, data, right? So let's see. Okay, good. It doesn't have anything yet. Chat. Okay, it's good. At least so far. At least it works. So we will. Yep. See, it uninstall version 4 and install version 3 because it would train. Technically, to be known as this is the a stable version, right? So that's where we at. Let's see. Okay, now we go to the next part, part 2, right? We're gonna create the document upload interface. So prompt. Yep, we're gonna have a prompt to create a document upload page with a page upload for MD file, component to upload, accept file filter, and Douglas. Let's see, clear creek is my example. Now add it in there. Title 2025. Okay, yes, 2025. We're gonna show preview of the data and create all the component, everything. Okay, good. Let's see how it built. Yep, so it will create now. It will work and create a template for us to upload the doc. Yep. Yep, since the instruction we told is to use Lien, it now using it to add buttons and everything. Okay. So apparently the legacy peer for Tailwinds kind of mess up the scene. We might need to ask Claude to force install version 4 and then change the setup to support version 4 for Tailwind. Well, first let us see how it built. And let's see how it's built so far. Actually, we can look at live. Local upload. Yep, now let's create upload with drag and drop functionality. a little bit we'll see it updated here. Oh, even create a sample doc for us. That's pretty cool. Interesting. Well, there's the upload functionality, but I don't see the actual drag and drops. Oh, let's ask this, right? So we can type ahead of time. One is let's change tailwind. This is give it a second, let it complete, and then we will refresh. If that feature is not missing, then we'll just resend the instruction in. Yep. So one less force it, one less force it to go back to version 4 of Tailwind CSS. And number two is we're gonna re-upload the section of the prompt that create a drag and drop and a UI to insert the metadata. So when you pre-select it, you're like, what data is it from? Okay. And things like that. So let's edit. Oh, in the prompt I put 2024 instead of 2025, but that's okay. Okay, has the upload, but still missing the drag and drop. So there's to another page. Sometimes the context is too large and has a lot of debugging, so it's pretty contaminated. We're gonna change this to 2025. Yeah, great. So this is a new clean slate. Okay, that's fine. You can see sometimes the list of instructions are sent, but the AI couldn't interpret, missing from that to do. So we just need to resend the instruction, a new one, and then it will just check if the file they exist. It will just resume and continue working on it, right? Updating it, changing it, make sure. Right, so it's already detect the component using a browser alert. And then it switched to using Toast, which is nicer UX. Okay, load component, so Toast, layout included, back and drag and drop. Oh, okay, so the drag and drop function is hidden inside the upload. So you don't hide the drag and drop and upload button. Yep. Drag and drop area is hidden until click on upload document. Interesting. Oh, okay, now is it's still hidden inside this. At least now we have a document that we can upload and select. Yep. Yep. This is what we want. There's no need for complication, hiding it beside button. It's just extra click, not very UX friendly for what we're trying to build here. Alright, and we're going to click this so we can drag and drop. And in the meantime, I'll copy the sample document. So let's see, sample document. I'll paste it in here. Oh, let's see. We'll find it and give it copy. Okay, click is our data. Let's see. Let's close that. Okay, this is done. No toggle button. Yep, that's what we want. Let's see, drag and drop. Oh, okay, see the UI works. Okay. Allow us to select reason. We will clear this. Okay. Okay. File browser works. For some reason, because probably, well, we want to drag from this folder, alright. Okay, that worked. Yeah, dragging directly from Visual Studio. It's not the same as in the perspective file browser, I would assume. Yep. Well, we can do the redemption guideline 225. Okay, we think okay, you can see the instructions, preview content, or have a quick upload. Okay, toast notifications, good. Nothing broke. We haven't implemented the backend yet, so yep, that's correct. The workflow, the UI does work now. Okay, cool. Let's go to the next part where we will be working on the chat interface, right? So let's copy the prompt and we'll go to the new, close this and this. Well, here we'll create the chat interface where the user can ask questions about tax lien rules, right? And that's where the application will be able to respond. just put the to-do plan here. We'll create the interface for the chat input, and then the styling. Okay, cool. You can see the chat area with the text, and the bottom where we can ask about specific county or all permission search. Pretty good. I think the only feedback I would have is if we on here feedback page auto login auto the yeah, the only question is this section is too big, and so it kind of like auto scroll down. We lost the menu bar. In reality, we shouldn't lose it at all. It should always at the top. Oh, okay. Yep. The height should be fixed. Yep, only the chat should be scrolling, not the interface itself. It's good, but understand it. Look here. So let's test and test message, right? And we should see some UI change. Oh, yeah, thinking. Well, great. User interface good. Sources and things here with the way and thinking icon. That's pretty good. So the next part is the document processing for the markdown. And let's show an example. So this is the document. If you look at the markdown, this is what as a user should see. This is similar to the markdown process file formatted you see in GitHub or anywhere else. This is actually how it looks behind the scene, and we're gonna use this way of truncation to split this into chunks so that it can create a vector with a meaningful create meaningful vectors. So yep, let's close that, and prompt here. New prompt. Well, the part of this prompt is creating the the doc upload and processing API, right, for the markdown. And it should have everything you needed. Create a MD processor with a split into with chunk size and not overlapping based on the header and each section header. Then we make sure we create all the interface with the document chunk where you chunk it with the ID and the content and the metadata, so we know when we're processing it. Upload it and production and logging. So let's see, let's building. Okay, so this is where the MD's parser file is, and you see parse the markdown, and this is where it gonna find all the header and position of the file inside the file, so we can split it, basically chunk it up into separate chunks, right? So we're gonna chunk it up by certain amount. So how does this work? Of course, when you look at the data, of course this sample data is small, but for actual usage outside where you start uploading your doc, these docs, some of the docs gonna be huge and long, and is how it works is let's say we're gonna chunk the text based on a certain context, based on the header, based on the section, whatever we term, and we're gonna chunk it. Let's say this chunk gonna be the first vector, and this second chunk gonna be the second vector. So each group have meanings. Of course, you can chunk by size. Let's say if you specifically, hey, I want to chunk by 500 characters, 500 words. But if you're doing that without actually knowing the structure of the text, what happens is the data gonna be chunked randomly here. Like grab first text, go with here, and a lot of time you might lose meaningful context because the first part of the sentence or the paragraph is here, and the second part belong to the next vertex. Next vector. Sorry. So this is where we might lose meaningful because maybe none of these words are similar to what you're looking for. However, it is the second part to explain the actual data that similar to your search query. So therefore, you have to know your truncation, how you chunk it, each section, how long is it, why you chunk it that way. And essentially, we also do chunking overlap as well. So that means we're gonna chunk here plus an extra amount. So we overexpose the context a little bit. So if we search something fall into the area where things are overlap, then it grab both vector, right? The initial vector information before it and the information right at it, so that you have a long list of context to give it to the LLM. So it will, have a meaningful long context to read through and see if your query makes sense or has context to support it. Okay, we see it. The chunk and size 1,000 character, default by chunk size, overlap of 200. Minimum is 200. Okay, so I would assume that it is maximum, so make sure that the section. Okay, everything seems to be good. Look perfect. Okay, great. Yep, and then the next part we're gonna be doing is setting up PostgreSQL plus pgvector integration. So how does that work? Well, before we get the prompt to create the pgvector and the logic to calculate embedding, we need to actually set up the database itself, right? So I'm gonna go to railway.com and do some of my project. Railway is really cheap and powerful what it is. And when you sign up, they give you $5 to use for credit. And how does Railway work is you by default for the Happy tier is really cheap, but for for the upgrade you purchase the bandwidth basically, and then they charge you get by default you get a credit for it monthly, and then you can use up to it. If you pass, then you pay a little more. So what happened is I paid $20 a month, and it give me let me see, I have post some here, settings, a 32. So basically your plan, you purchase the maximum bandwidth, put 32 CPU and 32 gigs, so I can give it a crazy amount of power. Now you don't get charged unless you use it, so you can give it a lot, but if it's barely moving, then you pay by that amount, right? So all these are share resources. So, I will give you referral code so you can get a free $20. That will last you around 4 months if you convert it. Yep, that's a lot. It's a lot cheaper than Google Compute. Google Compute pretty powerful. GCP is really powerful. As long as you know what you set up. There's a lot of things in there, but you have to set up manually. This remove that for you. So yep. So set up Postgre with pgvector, so we can actually see how the data is being vectorized. So we're gonna create so by default here on Railway Postgres template does not have pgvectors in there, so we're gonna create one from template. So we're gonna search for pgvector, and this is it. We're gonna create it, pgvector, deploy. Yep, from template. Cool. We can initialize it. By default, you can give it maximum resources. It's too much. You don't need that much. Sure, you can just leave it here. We'll give you a warning, but not too important. Oh, there's a lot of differences. By default, Postgre will give you a data view where you can directly create things inside extensions for Postgres. However, when you do the pgvector template, it kind of a specialized one, so they have to run it in Docker, and because of that, they don't have direct dispose of the data in here. But we're going to install pgadmin and Postgre Code, basically the UI for you to look at the data itself. And look at this, it's work. So we can redeploy it with the low setting that we just put it down, and in the variable for this you can rename it anything really. It does not change, it does not matter. This is for YouTube, so database URL, this is private, this is public. Yep, this is a public endpoint. You can copy it and go to your actually let's create a new file .env, simple, copy D2. This will be your open AI API key in the database for Postgres. Let's go back here, copy the public database URL. Oh, there's a difference between, for Railway, there's a difference between your public and private connection. For private connection between, this is within the internal network. The traffic is free, but if you do direct communication with database on over the public, you will get charged by the volume for ingress. That's egress. That's what they charge. So copy, put it here. I'll delete this after this project, so it doesn't matter. You can see it. And then I will also put in the OpenAI key. Yep, put the key there. Okay, cool. Now the next thing is we need to install Postgres so that we can create the pgvector extension. But for now, we can move on to get a prompt. But as you can see, once you have everything set up, create a new project is easy. Go in, click create from template. Within 30 seconds, you already have a a database hosted to be accessed anywhere for production, for dev. So prototyping extremely efficient, very fast, and you can visually see the data. That's the nicer part, right? Help you understand stuff. Yep. Right now, let's go to the next prompt so that we can see the back end. Okay. And this time, it will create the other process needed to control the process client, embedding logics, vector store, so you can store into the database in vector format, and it will also upload the data to Postgres and test functionality. And in the meantime that this is being set up by Cloudy, you can download PostgreSQL or pgadmin4 so that we can use to visually access and look at the data. PostgreSQL is pretty nice and quick, and then how you're gonna access it is through the exact same SQL URL here. I can show you. One thing for pgadmin 4 is the current version 9.8 is pretty well, the version 9.8 is buggy and super slow due to some incompatibility with the Electron framework that used to build the UI. So this is actually version 9.9. So if we go in pgadmin admin 4 and you go there, yep, download 9.9. This below will give you a very slow experience, so use this 9.9. Okay, now how do we connect this? Well, let's go back to the server. Oh, it's already connect for me because that's the last. Okay, register server name YouTube pgvector, and connection host name. This is where we're gonna use our this behind I have sign port and main database Postgres should be, oh, main database is this railway. The username should be the same. Password, yep, password. This is your username. This is the password. The second is the password before the @ sign. And then you're gonna save it so it doesn't ask for it. SS mode, leave it prefer. Don't change it to required because railway setup currently don't have SSL. So, and we're gonna save it. YouTube PG, open up database, railway, there you go. A schema, public, you're gonna see your tables. Currently there's nothing in there yet. Okay. Now setup for PostgreSQL is actually very easy. Click new server, name it YouTube pgvector. Actually from URL. Copy whole URL, paste it in, add server. Trash this one. Yep, it automatically fill for you, which is nice. To change the name, YouTube actor, and you can test it. We didn't test. It's good. Connect. Nice. Do query. There's no table. That's fine. Close it. Okay, cool. Yep, set away in your restriction, ensure ingress. Yep. So everything should be good. Now we need, let's start it. So it should initialize the table. Def. Oh, there's another instance that's running. That's okay. What is an issue? Oh, some iteration. We want to the error in, so we'll go ahead and fix it while we're working on this one. Oh, yeah, I can't mess up. Okay, fix now. Okay, let's do the recent clear crick. Let's give a let's check the data actually. Refresh. Oh, no table yet. Copy right here. Select a county, and then we can test upload. Success. We haven't seen it yet, so let's see if it actually. Oh, haven't. Okay, let's see. Oh, okay, it's fixed the error. At least let's check if the database, the person claims. If it's in the logic, maybe. Oh yeah, we haven't run yet. Okay, it shouldn't. With respect to extension, it requires tables for any vector operation. Okay, good. Okay, yeah, we create a backend, but we haven't connected with the front end yet. So that's fine. That's the reason. Yes, the code here will connect with the Postgres, and then it will create the extension to run vector, right? Create extension to run vector if that exists. That's great. Okay, good. We fixed the formatting hydration, and we already have the W0. So now we can update the query and answer pipeline. Basically the back and forth. Copy prompt, paste it. Yep, it will go through and create the chat query API endpoint with RAG train. So now it will retrieve, which is going to the database and pull the vector. And answer generation, basically create a prompt to send to the LLM models. Okay, so now it's working on the backend API for this. Oh, no, I mean, not this, but this. The user. Okay, let's see what has it built so far. Okay, for the retrieval, create all the necessary interface. That's good. Retrieve relevant chunk. The minimum distance is 0.5. We are using the cosine similarity. Okay, so this sign here is the cosine similarity for vector distance. That's good. Execute the query, have the enter the result, filter the distance. It's good. Okay, gonna format the context when you're putting back to create a prompt for LLM. Yep, this is great. And the context will be push into the body. Good. See the embedding size actually. Check the keys. embedding models. Where do we put this? Oh, rack config. Oh, in constants. Okay, constant top 5 result, maximum threshold 1, 2. Okay, small. Yep, this is the dimension that I was mentioning earlier. That we're using this. So this particular model only have 1536, which is already very good enough. If you want more, double this amount, then you can use the 3 large. And how does the model work is each, because this dimension, the certain size on the data, and the larger model, the larger size of each record that you're gonna be recording. So you can scale down the dimension, which occupy less space on the database, but it's gonna give you less accurate result. So this is a good size. Yep, it's gonna create the embedding right here, generate the embedding. Yep, input the text and the dimensions, and yep, we're gonna store it to the database. Great. Okay, cool. Yep. So we done creating the backend API for the chat. Now we need to connect the actual backend with the front end. Right, so this would remove the temporary message and actually let this connect with the front end with the backend. Okay, cool. So we're gonna connect. As you can see, it's connecting the API backend with the UI for the chat, and then after that, you're gonna connect the backend and the UI for the document upload, routing for fetching, polish the user experience. It's good. And then we can actually test the uploading process itself. All right. So the database should create a vector where we can see the vector itself by visually querying the data. To confirm that it worked, right? Very cool. Oh, it has a filter by county up here. Search by. Okay. So might some confusion by the AI up here, but that's okay. We can clean up this afterward. Okay. Everything should be connected. I'll refresh it. It's working good. Back to the data part. We have 0 document. That's correct. Oh, failed to fetch. Oh, okay, the database doesn't exist yet. Okay. The initialization should have triggered, but it seemed like it didn't. Uh, well, yeah, technically you can initialize by calling the backend directly for the first time and then run it afterward. Would have been nice to automatically initialize, but we wouldn't want to waste resource on every time you instantly you run this. You want to it will check as a recheck. Yeah, we are 301, so it's port 3000, so it's probably the other instance that's still being run in the background by this. You know what? We can actually trigger it ourselves. Dev. And then what we'll be doing is copying sure here. Oh, okay, it worked. I was about to run it. Oh, now if it does work, let's refresh this. Why is it check for local? This is check for ENV. Oh, check my local. That's fine. We can rename this local. See. Check my local. That's fine. And then 2001. Yep. We're gonna still rerun the initialization. Seems like the API didn't call. Yep. It works. Should be. Refresh. Oh. We checked it. Go back. Interesting. It might have some hidden background process that's preventing us from doing some stuff. Let's kill that. Close it. Oh, I have to call post this. Okay. So run def. Oh, it's still not killing the background. Let's find node and kill node. Yep, you can see node here. So you can kill it. Kill it. Yep. Kill it. The background. AI started. And run diff. Yep. Now we are good. We can ask it to run for us. My house is up in 14,000. Help me in this. Wise to DP, please. Oh, okay, cool. It's able to post it, initialize, connect, create, and everything. Good. Refresh it. Nothing broke. Let's minimize, open up our database, schema public, go to table, refresh, yep, document chunks, good, very good. And same posticle, refresh, yay. Great. Now, what should work is upload docs, your data. Oh, not this data. In my recent download. Oh, yeah. Okay. Well, what I learned while testing is that sometimes you don't see the text formatting inside the data, and it can cause corruption when there's a lot of weird characters that will mess up the vectorization. So you can ask the AI actually to clean up data, or just go in and remove a lot of icon and things that doesn't help really much. So now we should be able to see the database, ingest the data, chunk it up, and vectorize it. Let's upload it. Nice. Yep. Toast information. create into 8 chunks from 6 sections, and you can see in the back end is able to detect all the different create chunks, different section 1, 2, 3, 4, 5, 6, 7, 8. Very nice. Yep, it creates store in text embedding with 1536 dimension. Then store the 8 vectors into PostgreSQL, right? So this one is not magic anymore. You refresh it, select well, we can say select star from document chunks SQ. There you go. A bunch of IDs. The natural vector ID, your document ID, the actual content of it, and then a bunch of other filter or categorization that you can add in. You can add as much data in there. As much as you need to be able to effectively search for your correct data. Since that essentially for any businesses, essentially this database will be able to store of your SAP for different projects, for different departments, and for even different businesses within the same company. So as you can see, they're gonna be like maybe 10, 20 different layer of section in ID, time, truncate, project, sub-project, department. So everybody, as long as you can follow the standard, the whole company can share this, and it create a centralized knowledge base that is factually based on documents or your source of truth. So this is where it is. Now we confirmed it, able to vectorize the data. We're gonna go back to UI, start a chat, right? I'm gonna ask some specific and then some unrelated questions. So let's see. Let's see. Oh, okay. How much interest actually earned? It has no relevant chunk. Okay, it has no relevant chunk, and it's just empty. We're gonna fix that. What document is required for redemption? No relevant chunk. And calculate the total redemption amount. No relevant chunk. Okay. Make sure that we are county equal all. Okay. Let's add something specific. Based on the dog, and then we can test it that way. And if it's not working, then it could be several problem, right? Okay, copy that. How long do I have to wait it out. Questions? Interesting. It doesn't have anything, right? So now we're gonna be able to ask the AI to make sure certain things. Is the no? Are we using cosine similarity? To calculate this vector distance. Okay, good. At least we are using the correct distance. So our question gonna be maybe. So let's put this scenario. I put in query. Quick MD file. So what happened is, since we already installed PostgreSQL, the AI actually go directly to the database and query it to validate our questions on why we put in the query, but it did not work. So actually, the test query, huh? Good. So I can see here. Oh, I found something to recommend. So what happening here is, I think the weighted out chunk had a distance of okay, yeah, it capped the distance is too aggressive, so this kind of relevancy got filtered out. So we pushed the threshold out to the max. Oh, so we did create it, but we hardcode 1.5 here. Okay, so with the test, we'll refresh it. Oh, there's some hydration. There's some hydration HTML error. Okay. Let's clear this out. Yeah, so we need to. Oh. So make sure that let's delete the no modules, delete. Install. So go to the buttons. Okay. So yeah. Why does give error? Why do we need line check? Yes. Okay. Yep. I think during the setup process, the AI got confused and started installing packages that we don't actually need, and then it caused confusion and version conflict. good. npm install, just check on outside, really no issue. npm run dev. Awesome. Refresh. That should not be an issue, but you know, there's always is, since we're using the latest version of Next.js with 15. I can see a lot of the new error. Browser extension. Sure, we can suppress the hydration warning. Okay, fine. It should be working now. Okay, great. Now what we're gonna do is we're gonna ask the same questions. How about interest? No Roland, that's fine. Copy our initial questions as we try to fix. Okay. The filter none. We need to find what the issue is. We also need to make sure that we are vectorize using the same dimension both with the backend data and also the query. Okay, so let's try it again. What we can do is go back to the upload process. Oh, on the day side, let's see what the issue is. The formatted day. Okay, probably out the list, document list. It's list out the the document data inside the database. To make sure that the embedding is using the same dimensions. Same hydration issue. Okay, should be fine. We will delete this, wipe everything from the database, refresh this, run. Yep, everything's gone. Re-upload data, drop it in. Now, if we could upload this, do this, refresh, that's fine. The error comes from this. Perfect, okay. Chat. I'll find relevant chunk. Assuming is true. And the response is broken. Okay, it found the chunk. Okay, good. Generating answer. Okay. Good. API. Need to tell that but the text on the streaming chat response is messed up. Complete copy. We're gonna give it so streaming. It's streaming back word by word. You see here the content, yep. But then the chat forgot to clean out the JSON. So let's copy it out again. Fresh. Well, I should work. Awesome. Yep. Have to wait for 7 years to challenge the deed. And wait after that. Ah, nice. It has references to where the data is. Good. See, the context is sent back to the general model, and the general use that to respond it back to us. So refresh it. How much interest rate do I earn? Okay, see, we need to know this. If it doesn't have any information, then it would just say it doesn't know. Great work. What's the document required? Yep, it doesn't have it. Calculate. Yep. Now this it's feeling weird. Too weird. So let's confirm it a little bit more. So copy this and ask how to contact the treasurer. Yep. For the Clear Creek County, if I do Boulder and I ask the same questions, it should not. Oh. Oh, the search in filter. Oh, Boulder. Oh, okay. We can definitely fix this. So it has the bottom, but then at the top we have to do filter on chat UI. We combine and move the two on top of text input. Yeah, I want to put it here. Let's yep. Oh, nice. Okay. Remove it at the top. Yep. So basically, first it remove the duplicate. Doesn't work. Then it move it here. So let's check. Let's filter. Oh, okay. Need to fix it. This is considered UX issue. Issue when no chance is found. AI response is empty, and that's not good. With our assumption that the AI will understand that the no chunk file would be similar to chunk file that far outside of the relevancy. Filter. Yep. Make the edit. Okay, cool. Fresh. Random. Put it in. Yep. I couldn't find some. Okay, click. Search it. Nice. Good. Sure. Delete. Oh, good. Confirm status. Basically, the raw text or information for the knowledge base is given to the general model, and then it come back and it put into its own word or reformatting and put here. Well, there you go. A fully functional RAG application that you can use to build and upload any information that you want for your business, for your project, and then you can start asking the AI about the data. So hopefully this tutorial has been useful, and stay tuned for more tutorial. So if you like the video, if you think it's helpful, please like and subscribe, and hopefully we will see more useful tutorial for you. Thank you.